Thank you for inviting me. Uh, so I will maybe for this session I am the last speaker and will close with. So far, what we have seen is an overview or of various challenges arising from data or innovation or societal problems. Now, we will pick one problem and examine it in detail. So, as an engineers, our focus is to solve problems. So, most of our work is very narrow for a narrow audience who has technical background. But I will try, and also have tried to make this presentation that is suitable for audience who are not deep uh, into technology or mathematics, but still you will see uh, what kind of opportunities it creates as a student or those who are in industry, what application they can think of. So this project, the presentation I'm giving is result of my collaboration with Mitsubishi Heavy Industries. Has anybody, do you know that name? Anybody? Yes. So what kind of products do they manufacture? Yes. Say it loudly. Or
Elevators, heavy
elevator.
machines,
What do you mean by heavy machines?
processing machines.
Okay. What else? They are very big in ship building, you know, and recently they have also started manufacturing aircrafts. So it is one of the oldest and biggest business house in Japan, and we worked with them for almost 3 years, from 2016 to 2019, and the problem that they brought to us earlier. Earlier they were very skeptical. They had collaboration with IIT Delhi and Tsinghua University in China, which is one of the best universities of China, and it was not successful. So, but they came here because one of the students of IIT Kanpur has done well, and they were hopeful that they could have some good collaboration from this institute. So let me explain you the problem framework, and I will also get into the nitty-gritties of this. So this project is on job shop scheduling. So anybody has taken the course on scheduling or has heard this term in the context of MBA? Yes, one students, among students, have you heard this term scheduling, job shop scheduling, flow shop scheduling? Okay, so it is, I will give you a brief background that this kind of problem also arise in day-to-day life. So for example, let's think of now healthcare scheduling is becoming a very big problem. So when I'm talking about healthcare scheduling, so there are limited doctors, limited ICUs or emergency rooms, limited resources you have, and you have you can have objective in terms of some person being very critical. So overall objective would like to have that less mortality or less casualty, right? But all patients are treated. So how you prioritize these doctors, nurses, rooms, equipments you have, so that almost all patients are treated by their due date, or due date here is some reasonable date by which they should be discharged, right? So here scheduling is also, we encounter this problem frequently during class scheduling. So all those who are in academics, they know at the beginning of semester there is so much hectic conversation among all colleagues to schedule which class will be scheduled in which room, and we have to be also careful that students who are in the same batch, those courses should not be scheduled in the same slot, so that there is no conflict and all those things, right? So similar problems we also face in manufacturing industry, but at a large scale. Scheduling is a technique widely used in manufacturing and services industries. So what we mean by scheduling is allocation of resources. So here resources are not limited to machine or or we can think of space. even space we can think of as a resource, or human is also a resource. So our resource is not limited to machine, but we are broadening this term to include human, space, and also machines, right? So refers to allocation of resources to different tasks. So think about a patient who has been admitted into the hospital. Our objective is that patient get discharged after treatment. So that is the complete job. But it will have specific operations, like if the person needs to be operated, then first there will be blood transfusion or blood test. So these are specific tasks we can think of, right? Over a given period to optimize one or more objectives. So in services industry, the objective usually is what? Don't miss the deadline, right? That is one of the thumb rule we use, that missing deadline is a kind of big penalty, but there are other objectives we can also think of, like lead time. Anybody knows this term, lead time? Okay, so lead time is from the time duration from the start of job to finish. And also finishing a job early is a problem in many industries, because if you finish job early, then you have to suffer a cost of inventory, right? Or it may deteriorate. So all three objectives in this case you have to keep in mind, that don't miss the deadline. Lead time should be small, because if your lead time is long, then all your machine and equipments are on for a very long time, and you incur cost, and don't finish early. So that comes in objective. And so representation of any problem, we have pointed. Okay. So representation of any problem is a resource that I explained, and processing, that refers to conditions. Like I said, when we are scheduling a classroom, then two courses for the same batch should not be scheduled in the same. Okay, and like. Oh, okay. 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 So processing, I was referring to different constraints we have to honor, like one operation must be done before the next operation, right? So those kind of constraints we are talking about, and objective I already highlighted, right? So when we have multiple objectives like earliness, lead time, and tardiness, and we want to meet all these objectives, usually in most of the time objectives we follow is like tardiness we want to minimize. But this term was popularized by Toyota in 1980s, and this terminology is called just in time, that you want to finish an operation just close to the deadline, not too early, not too late, right? So just few terms that we need to be aware of. So general setup in the context of job shop parlance, we can think of in this way, that there are end jobs to be scheduled on M machines. So end jobs, you can think of production of a car, production of an aircraft or ship, and many of these specific products will share common resources like milling machine or painting. So resources will be shared among these jobs, and each job requires a number of processing steps known as operations, and each job has its own predetermined route to follow, which operation has to be done first, next, and so on. And those who have done a basic course on scheduling, they will know this term, that this is an NP hard problem. That means algorithm time solution doesn't exist. So most of the time we use some sort of heuristics. What are heuristics? Anybody? What are heuristics? That you should be able to answer. Heuristics? What are heuristics? Heuristics are thumb rules that we use in day-to-day life to solve any problems, right? So most of the time we come up with good set of thumb rules to solve this problem. And in research, academic research, we know that special cases involving one or two machines, reasonable solution you can achieve using some algorithm known as branch and bound and shifting bottleneck. Okay, so here is an example I have demonstrated about the problem that setup we are working with. So let's say I hope it is visible to all audience in the back, but I have highlighted them in different colors. So yellow is the one job, red one is the second job, and green one is the third job. And their release date means when the job was released, and it came in the flow shop, and due date. That means this job was released at 9 a.m. on 4th April, and it must be finished by 3 p.m. on the same day. So and it needs 3 operations to be finished. That operation 1 requires 120 minutes of processing on machine 3, then 240 minutes of processing on machine 2, and 60 minutes of processing on machine on M1. So total time, if you see, is what already 360 plus 60, 420, right? 7 hours. So we had those conditions that there were jobs. Even if you have almost all resources available, you can't finish it before the due date, and that also happens in real life, right? And so example solution of this using a heuristic would be that is represented here. You have these 3 machines, M1, M2, M3, and these are time slots from 9 to 10, 10 to 11, up to 8 to 9 p.m. Right? So this M3, we have first schedule job 1, which is yellow color, on M3, then on M2 and M1, and then job 2, which is in red color. The slot is available here, so get scheduled here and then here, and then job 3 gets starts. It needs first machine M2, so it starts from here because it can't be processed until this machine is available, and then this job. Right. So this is an example solution. Problem 2, things we should be aware of is release date, when the jobs were released, due date, that I already explained, processing time on each machine, sequence, precedence relation for each job. Each job has different precedence relation, and time horizon here is 1 day, right? So this is a very simple problem. Horizon is simply we have a small number of jobs that need to be processed within a day. So performance metrics that were given to us to evaluate the algorithm were these 3. They were lead time. Lead time is T is minus S, where T is finish time and S is start time. So how long the job was in the shop. The second one is called tardiness, which is anybody knows this notation? Yeah, positive part. It's called positive part, or only if it is negative, then this will take a value of 0. Otherwise, it will have positive value. So how many you can think of? It quantifies all jobs which have missed their deadline, right? And then this is quantifies all jobs which were finished before deadline, right? So these 3 objectives we have to keep in mind, that all need to be minimized: lead time, tardiness, and earliness. Okay. So how I already highlighted that most of the time to solve this problem we resort to heuristics, which are basically some sort of thumb rules to solve the problem. heuristics are an informal, intuitive, and speculative procedure that leads to solution. And in the context of scheduling, heuristics are dispatching rules. And some of the terms you would know, like first come, first served. It is used in canteens. Those who come early are served first, and those who arrive late are served later. So that's first come, first served. It is one heuristic. We can also have heuristic like early due date. So the job which has early due date will be processed first. So we can come up with various heuristics, various dispatching rules, and maybe thousands of them, and then we don't know which one. Basically, our job is to identify which heuristic works best for which scenario, right? That we need to identify. That we need to figure out. What are the factors we have to consider, such as scheduling environment, such as machine requirements, due date, release date, and others. And examples of dispatching rules I already mentioned. So in scheduling literature, one of the famous algorithm for jobs of scheduling using any heuristic is Gipler-Thompson algorithm. In the interest of time and audience, I will not go it in detail, but this is the benchmark solution that is used, but it was of no use to us. So now coming to the problem that we had to solve. So what the problem they wanted to solve is given here. So they wanted to solve the problem which they wanted to an algorithm that could solve up to 250,000 jobs. That leads to scheduling up to 6 million operations, and time horizon is up to 10 years. So they had big contracts with government, and some of the contracts would take 2-3 years. So time horizon for scheduling algorithm they wanted was up to 10 years. And there are specifics that each job varies in terms of number of operations. Like number of operations we can think of from 1 to 200. A job could have 100 different operations. Precedence relations could be different release and due dates, and resource requirements would also be different for each job. And we have to also keep in mind the resource constant. So some of the resources are, their quantity is, their availability 24/7, like transportation, and they are available in infinite numbers, we can say, or large numbers. So if transportation is the job, it will never be delayed. But there are some jobs whose quantity is 1 or 2. You can think of as bottleneck resources. That many operations will require that resource to be processed. And each resource has working calendar. So that is the important thing that is not discussed in most of the scheduling problem. That here resource we are not limiting as a machine. It could also be a person. So person has a working shift. It can work from 9 to 12, then there is a gap, and then from 1 to 4, and then we can only schedule an operation using that person the next day, right? And why we need calendar? Because we do not have all working days in a year. So there are holidays and so many other factors come in. So, or weekends. So we had to take all those account for this time horizon for the next 10 years. So you can think of that there are different time slots for these resources. Please let me know how I am doing on time, so that I don't stand in between. Okay. Okay. So I will at least describe the problem and not go into the technical details. Okay. So let's understand what I'm trying to say visually. So precedence relation, when we talk about that one operation must be scheduled before the next operation. So here is operation 1 and operation 2. And before, and these operations could be scheduled in available time slots. So that I highlighted, like you can schedule, for example, we can schedule operation 1 from 8 to 12, and then there is a lunch break that must be honored, and then we have to schedule operation 2 from 1 to 5 p.m. And then we have to take into account the calendar of the next day. So if we are looking over long horizon, so this is typical representation over a weekday. You have breaks, and in between 2 days you have long break that would be the night time, and then there is also break during weekends, that during which we can't schedule an operation. So in this project, the major problem was coming down to finding a valid working slot for when we have large number of operations of million orders, and when each job is scheduled, we have to update the availability of that resource, right? So finding a valid time slot for the next operation was becoming algorithmically very demanding. So that's what we have mentioned here. We have to, when we want to schedule an operation, first we have to determine the processing time, how long the operation, how much time that operation takes, which machine will be used to process that operation, and identify a next available goods slot using the calendar. You honor the shift constraints while scheduling the operation and update resource quantity. And once you schedule, if it is an unlimited resource like transportation, you don't need to worry. Okay, it is in thousands, I have thousands of trucks, I don't need to worry. But if machine is very critical, then we have to update the quantity of that machine. Let's say quantity is 10. So one resource has been scheduled, then we have to update the quantity of that machine after scheduling that. So a typical availability on a machine would look like this. This is the time horizon and this is the quantity of a machine. So for example, up to this time slot 0 to T1, the quantity is 3. Then let's say we have scheduled an operation, so quantity during this time slot has been reduced to 2. And similarly, during this time slot, if we have scheduled all 3 operations, then its availability is 0. And then again, it could vary depending on how an operation has been scheduled. So what the problem we were facing is that when these bottleneck machines, whose quantity is limited, when the machine is highly occupied, we were facing many unsuccessful searches to find a valid slot. And that was, as I mentioned earlier, that was increasing the runtime of algorithm. So I did not tell you what was the objective. So they wanted this problem to be solved within an hour. So a problem which would take more than an hour was not acceptable to them. So that was the major challenge we are facing. Earlier, when we started, it was taking more than 3 hours. We finally tweaked and brought it down to eventually 48 minutes or so. That's what I have mentioned here. Initially, it took more than 3 days with high CPU and memory to get a reasonable solution, but eventually we solved this solution. And the solution came not from scheduling research, but came from paying careful attention to data structure, and scheduling was, it will come later, but kept an algorithm design. So I will skip this. This is slightly technical, but the data structure that was most helpful for us in this case was hash map. Anybody who knows programming would know this, and implementation of binary trees with B trees and red black trees. So I will skip this. This one also I will skip. So I will give you an overview of solution that we came up with. The solution we proposed uses the idea of blocks. So what is idea of blocks is, idea of a block is continuous processing time or continuous processing time that could be used on a machine. So for example, this is an example of a block. So here we have availability of resource, and this is time. So for this particular machine, these are the availability of resources at different time points, and during this time interval, which is a break, it is that is, so we have to just honor the calendar. The resource quantity is not going to 0. So it is a valid block because I can start an operation here and finish until this time point, right? We just have to take care of the break. But once the quantity reaches 0, then I can't schedule another operation on this machine. So there is a break in availability. So idea of the block is that it is partitioning the available time slots in different groups, right? So let me read out what here a block partitions working time slot, and processing of an operation is not allowed across multiple blocks. So we may have multiple blocks and multiple slots for each block, and we had to efficiently store these blocks available on a machine and multiple slots. So these are all slots within this block. Efficiently store each of these slots for each block. So that was the basic idea about solving this problem. So let me recap. There are many things I discussed. What the major things that I want to highlight is that job solve problem is NP hard. That means it is difficult to solve using good algorithm in a reasonable time. And for large scale scheduling, when time horizon could be up to 6 months or 1 year, retrieval of working slots we faced was a major bottleneck, and it has we found almost no reference in academic or research literature, because usually in academic literature the emphasis is on finding optimal schedule for a small scale problem. And the famous test case, if you search on Google, you will find is that it is considered FT10, which is 10 machines with 10 jobs, is considered one of the widely used benchmarks. Or if you search for large scale, I am confident, I don't think you will find more than 10,000 operations. And here we were dealing with a scale of 6 million operations. Right? So that's the difference of the scale we were dealing with, and we are still working on it, and we are hopeful we will get some good, academic out of this collaboration too. So that's one part. How I am doing on time? So tell me this. Okay, so I will wrap up. So let me skip these other things and we'll go to the machine learning. How we can, I am sure you would have taken a course on machine learning, and that is one part where they were interested in using machine learning for the selection of dispatching rules. So So I told you dispatching rule is basically a kind of heuristics, and we can have thousands of heuristics we can think of. So our job is to identify, given a different shop conditions, which dispatching rule would be appropriate. So let me give you I will skip also this, just come to the example that all of us could relate to. So the problem is known as multi-level classification. You would have heard about multi-class classification. So how multi-level classification is different, and that is the kind of problem is similar to what we are trying to solve when we are dealing with this. So let's consider this online movie rental called Bollywood Fan, and it wants to develop a movie recommender system. So all of you would have come across this recommendation algorithms where you are shown which news is relevant to a person, right? Where that is called personalized news recommendation, widely used by Yahoo and Google News. Similarly, Amazon uses for if you have purchased a good, which are the products you could like. Here we are talking about fans, movies, that is widely used by Netflix, right? Netflix or now Amazon Prime also uses. So let's consider the genre of movie we for the moment is action, comedy, romance, sci-fi, thriller, and all. Right. So these are the genre of movie we have broadly classified. If we are talking about news, we can think of as different categories like business, national, international, and all those categories. Each customer has one or more favorite categories. So a customer can like a movie which is action movie, but she can also prefer comedy, right? So here one we can't attribute one class to a customer. There could be multiple class belonging to a customer, right? So that's the difference here when we are talking about multi-level classification. So coming to the scheduling problem, when we are talking about job shop scheduling, one dispatching rule, multiple dispatching rule could be appropriate for a given problem. So here is a typical profile for this problem. Let's say Hari, which her age is 35, his age is 35, sorry, male, government employee, and other details. And this is the call response variable. He likes art and family drama, right? Another profile is of Kavya, whose age is 27, female, pilot, and other details, and she likes sci-fi, family, drama, action, and so on, right? So for each customer, we have multiple categories, and now we have to develop an algorithm where when a new customer comes, we could identify appropriate multiple categories and recommend movies to her, right? So similarly, if we are talking about news, when a new customer has come, which are the new set of articles from multiple categories that could be recommended to the customer. So this is the what we are currently working on, and with that, I think I'm already. I will skip these details, and thank you. I will be happy to take any questions.